Good afternoon, all. Am I audible? Am I audible?
Yes, sir.
Okay, we will wait for 5 more minutes. Let others also join. Where are other people? Tell them to join.
सर आज का टॉपिक क्या है?
There are only 3% from mechanical. Where are others? CM and civil also. 3, 4 only.
Yes, we will only four.
Sorry? What are you saying?
सिविल में तो हम 4 ही है सर.
Only 4 are there?
Yeah, civil.
And mechanical?
Mechanical तो नहीं है.
मैकेनिकल में 8 है सर.
सॉरी 8 तो कहाँ है बाकी के? बोलो उनको ज्वाइन करो.
Absent.
एब्सेंट क्या? एब्सेंट क्या है? आप लोग घर से तो है, उधर कहाँ आना है? तो क्या है एब्सेंट? टेल देम टू ज्वाइन. मैसेज देम. वेट फॉर 2-3 minutes. Okay, it seems that no one else is going to join, but it is very sad actually that people are not taking advantage and rather taking excuse and being absent while working from home. You can't say absent while you are from working from home. You can't say absent. You are not attending. That's it. What else you need to do from home? Which later I see everyone who are present. Please listen to me carefully and please pass on this information to everyone, including chemical people, that I am also having your attendance record. Fine. Later on, when you will ask me some doubt, na, I will check that on respective slot you were there or not. Understood? I won't explain it again and again. It takes a lot of time and energy, okay, to repeat certain. It's not that we should be repeating one and keep repeating one thing. Understand? So, and next time onwards, if possible, if I feel, I will also lock meeting after 15 or 20 minutes so that no one can join later on. I'll mark him absent. If you are required to be at college, you will be attending. Why are you doing so? Okay, I'll share my screen. Is it visible?
No sir.
No, sir. No.
Yes sir.
Thank you. Today we will discuss epicycloid. Like we have discussed simple cycloids. Now we will, and then we also seen superior tropoid and inferior tropoid. Hope you all have done whatever I gave you as homework also. Is there any difficulty to anyone? Is there any difficulty to anyone?
No sir.
Okay, thank you. Now,
सर
yes, who is this?
सर वो हमने जो डिस्टेंस लिया है ना सुपीरियर का मतलब मैंने वो
Uh,
1 लिया है 1 सेंटीमीटर लिया है वो
fine,
चलेगा
no,
जीरो
no,
पॉइंट फाइव
no problem, no
वो
problem.
थोड़ा मिक्स हो जा रहा था इसके
No
लिए
problem, no problem. Fine. Basic thing is that you should know how to do that. Distance may be whatever. In exam, you may be given 1 inch or 1 m. That is different thing. You should be knowing how to complete that thing. That is more important. Fine. But as far as possible, stick to what is given, so that in hurry also I can if see what at times what happens. Teachers do it in hurry. Check. They know this should be the dimension. This should be the line. This. Suddenly see someone sees something else, and it can be easily presumed that if it is wrong or what the outcomes. So, if it is possible, stick to what is given. Otherwise, fine, no problem as of now. Okay, so we will see epicycloid. What is epicycloid? We had seen definition of that. What- here it is, epicycloid. If the circle is rolling on another circle from outside, it is called epicycloid. And if the circle is rolling from inside, then it is called Hypo Cycle. How this differ, that we will see. I have stopped sharing, just hold a second. Okay, so we will discuss today epicycle. Just hold a second. I'll just join in a second. 2 minutes. Okay, thank you. So today we will see epicycle. As we seen earlier, what is epicycle? Again, repeating the same. Anyone from your side? What is epicycle? चलो भाई आंसर दो फटाफट.
Sir, don't know. Epicycle.
I just showed you the slide 1 minute earlier. Were you paying attention or not? Epicycloid is a curve where we can trace when a circle rolls over another circle, or say curvature surface. Fine. So I will say the problem statement. Okay. Draw locus of a point on a periphery of a circle which rolls on curved path. Take diameter of this is this, etc. Fine. So if you break the statement, what is that? Draw locus of a point on a periphery of a circle. So what it is told that a point is there on some circle, periphery of a circle. A point is there. So that much is clear. Then which rolls on a curved path. So now a circle which is having some point on its periphery is rolling on a curved path also. Okay. Diameter of the rolling circle is 50 mm. Okay, so diameter of that rolling circle is also given. And radius of directing circle means curved path. Okay, so radius of that curved path is also given. Now we'll start to it. See, this is same as what we did in superior trochoid or inferior trochoid or whatever. And it is same. Only difference here is that in superior trochoid or say cycloid or inferior trochoid, the rolling circle was rolling on a flat surface. Understood? Here it is rolling on a curvature. That's it. That is the simple difference. Here it is rolling on a curvature, there it was rolling on a straight path. That much is the difference. Otherwise, the procedure is ditto. There should not be any doubt to anyone at all. You should be able to complete it fast. Fine. If you don't have doubt in earlier case, you should not be having doubt here also. Fine. So now these are the steps. Okay. Now we will start. Now, what is this? This is the radius of curvature. What is given here? We are given some curved path, as I can see here. We are given some curved path. Fine. This is the radius of that curved path. Now this is the curvature on which the circle will be traveling. Right now we are not fixing this length. We don't know how much that circle is traveling. Okay, we don't know that. So this is the directing circle. It is also called directing circle that time. It is also written here in statement. Directing circle or sectoral path. Fine, this much is clear. So what we did, we generated path on which our circle is rolling. Okay, this is the circle which rolls. Fine, this is generating circle or rolling circle. We can say it any by any name. Then its direction of rotation. Direction of rotation is given because we want see from symmetric or say initial position, we want it to move towards right, so it should rotate in clockwise direction, then only it will move towards right, because there is no space on the left side, so we are moving it on the right side. There is nothing significant about it. Okay, now what we will do? As usual, we will divide these parts circle. Okay, now this is the nomenclature given. This is the point. Okay, everyone able to see? This is the point P. This is on a periphery of circle and this will rotate. Understand? So it is rotating on this circle and this point we want to trace. Now this is a circular motion. Fine. So just understand my question carefully. If this point initial condition is this, then how much it should travel on this path to reach back to this original position? This point P is here right now on the blue circle. I want it to travel on the blue circle, this P point, and I want it to come back to its original position. So total distance traveled by that P point is
pi d.
pi d, correct. Why are you taking this much time? Don't get yourself confused. You know everything. Just try to give answers. Pi d distance. So ultimately, this will travel pi d here. Understand? If I want it to be back to be here. Now, what is the locus actually? Do you know that if something travels, for example, we are traveling in circular path. We started from here and we are taking 10 rotations starting from here in this direction. Uh, will that locus will get changed? Whether you travel 10 times or 50 times, will this locus of travel get changed?
No,
Yes or no?
no,
Yes, sir.
Yes or no? Again, what I am asking, this is my fixed path. I need to travel here and I am being tracked, okay, by GPS or whatever, something I am being tracked. So if I will complete one circle, I will be traced by a path, circular path. Then if I make 10 rounds or 50 rounds, will this path get changed? Shape of my travels will get
no.
changed or no? It won't change. Understand? So this this is just portion of the circle is shown. Actual image is like this, and our smaller one is like this, and the point of interest is this. This is the point of interest. So what I explained you earlier, according to that, this starting from this position, if means this position means it is touching both circle. This P point is touching both circle here. Understand? I will make it more clear. You can directly draw shape now. We will draw this shape. This is like is like this, and this is the point. Okay, our point of interest is what? Actually, what we are solving. Read the statement again. Draw the locus of a point on a periphery of a circle. So we need to draw the locus of this yellow point. Are you getting me? So that yellow point right now is touching both the circles, bigger and smaller. Now, is it not enough that we draw the locus up to the point where it reaches this position again? Are you getting me? What I told you earlier case, I am traveling in circular path. So if I want to trace my path, that one circle is enough. Even though I travel 50 times or 100 times the path, what I want to trace will be enough in one case. You getting me? So if I want to attain this position, though it will keep on traveling like this in circular motion, it will be rotating like this, but that rotation will be repeated after some position. Are you getting me? Currently, this point is touching red and blue both. After 1 minute or say, for example, 1 minute, this point won't touch this. It is rotated in this direction. So it will lift up from this and it will move towards this direction. So what will be the next position? The next position will be like this. We'll assume this as the same size, okay? And our point will come here. P point. It is also because it is stick to it. Now it is travel rolling, so this will get lift up. Understood up to this?
Sir, can you explain again?
Currently, this point is here. Yes, you keep answering yes, no, etc. Don't keep sit idle. If when I ask question, answer me. Currently, this point, yellow point is here. Is it visible?
Yes, sir.
It
Yes,
is touch.
sir.
It is touching both the circles, red and blue. Correct.
Yes.
Now this is fixed. This our red one is fixed circle. It won't change. This is fixed. This blue one is rotating, rolling over it in this fashion. Understand? So if I want to give one analogy, you assume one basketball and you assume one cricket ball and assume that cricket ball is traveling over that basketball. Understood? So that is the position. So now initially this P point was here. Now this will travel on over this. So this P will get shifted or not. You roll over
Yes, sir.
you roll some coin over your. I will just stop and I will just demonstrate one thing to you. Can you see this? Can you see this?
Yes, sir. Yes, sir.
Okay. Now assume this corner as a point of interest. That is our P point. This corner. Getting me? Now I will rotate
Yes.
it. See, it is being lifted. That P point is changing its position
Yes, sir.
as it rolling around it. The P point is keep on changing its position. It is still changing, still changing. It is still changing. It is still changing. Now it has reached to its original position. Correct or not?
Yes,
Yes,
sir.
sir.
What it was here, it has reached back here. So again I will keep on moving it like this. What will happen? This path which was generated here will be again repeated. Are you getting me? That P point again will start from here and will reach to that point, and again it will be repeated again and again. Are you getting me?
Yes, sir.
So the one reaching for the first time at its original position, that much locus is enough for us. What I want to emphasize, this point has started to move. Now again we get the same position where this blue and black intersect at P point somewhere here. It will be enough for us. That path will only be repeated throughout the circle. Are you getting me? We need not to complete whole thing unnecessarily. Then everyone can understand. Okay, this will be keep on repeating. Same way in cycloid also, what you did, you started from initial position where P was touching at a flat surface, and you stopped at the same position. So what you did for one whole rotation of P point. Here also we will do the same thing. So how much distance we should, there was that at that time it was easier because straight path. Here we are having curvature path. So distance is decided, means this how so up to where we should draw this. For that, this is the radius as usual. Now this is important. This angle. This angle is theta and it is given by this equation. You may note it down. Small r, that is the radius of this circle, blue one, divided by capital R, that is the radius of path, circular path we are having, into 360 degree. That much degree we should draw a line to. So that what will happen, do you know, by using this equation, this P point again will come back here at this point. P has started to move around like in this fashion, somewhat like this, and again it will come here. This is the only change. You need to remember this. That's it. Everything else is ditto same. And that's why I consume this much time to explaining this only, because this is the only thing what we need to get clear in this epicycloid or hypocycloid. This up to what distance we should take, arc distance this. Fine. So now we'll continue our process. What is this? This is done. Okay, so what we are doing? We are dividing. What we did? We first of all we did divided this in 8 parts. This blue circle. So we will also divide this circular path in 8 sectors. 8 sectors. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So we divided this also in 8 sectors. Fine. Now what we will do? This thing we also did in cycloid also, strocoid also. We extended one horizontal line from center point C. Here it is traveling in circular path. So what we are doing? We are extending the center line like this up to this, and we will mark different centers. This is just showing the final position, what its final position will be. That it is fine. If we don't show this is fine, no issue. This is just for demonstration purpose, so you can understand how this traveled here. Okay, so now we will transfer every point, these corner points. Okay, in that earlier problem, it was straight line. So we were extending a horizontal line from every point. Here also, ultimately we are projecting the things. We started lecture on projection of theory of projection also. Fine, same way. So we are projecting this point up to this line, up to the end point, like this. Every point, 3, 5, 2, 6, 1, 7, everyone. And we will give the center line point name as usual, what we do, C1, C2, C3, F3, F3. Now anyone from you will tell me next point, next step.
Radius
How much?
C2P. C2P.
Not C2P? Where is C2P? Acha, C from C to P. You should speak like this. Or CP radius. Radius equal to CP.
Oh,
Okay. Then
Then arches
but
from C1, C2,
okay.
C3.
From I will put my compass on C1. I will mark it. I will put my compass on C1. This is C1. Okay. Then where should I mark the first arc? On this.
फर्स्ट आर्क वो फर्स्ट, हाँ वो फर्स्ट से लाइन निकल रही है वहाँ पे फर्स्ट आर्क.
Sorry. From C1, that is CP's radius. Now from C1, mark the arc on line 1. This is the 1. Then this is its line. This is the line coming out from 1. So we will mark one arc on that. Like this. See. Correct? Understood or not? Same as earlier.
Yes sir.
Everything is changed. One thing only changed here is this. Theta. Up to where you require to go. In that it was simpler. You were drawing horizontal line equivalent to pi d. That's it. Here it is being curved, so we need to talk in terms of theta. That's it. Now, same radius will remain same. CP. R is equal to CP. Then my compass will be on C2, and line I will mark on line coming from 2. This is the line coming from 2. On that I will mark one arc like this. See. Now on C3, from C3, this is the C3 point. This is the line coming out of point number 3. We'll mark one arc on that like this. Now C4, from C4 to 4. This is C4, and line coming out from 4 is this. We'll cut one arc on that like this. Now C5, this is our C5, and what is the line coming out of C5? That is the same which came from 3. See here, it is coming from the same. So this is the line which is being coincide like this. So we cut on arc on that. Clear everyone how we are cutting the arcs? Any doubt in this?
No, sir.
Then C6 to 6, this is the 6, and C7 to 7, and C8 to 8. So see here, point P was initially here, touching the bigger circle. Again it came back to the same position. So now what locus will get here, that will only be repeated again and again. If you keep on drawing whole circle, the same path will be repeated. Now first of all, answer me, what will be the value of theta here?
240.
Calculate precisely. That is r, and one is here diameter, one is radius. So convert accordingly.
$120.
Answer me.
$120 degree.
Answer me.
120 degree.
So why are you taking this much time? Okay, 120. So now one question for you. Now one question for you. This kind of question can also be asked. Okay, at times. If you are not asked to draw whole epicycloid or something like this, or whole problem statement and everything is given up to this. And what you may be asked, now listen my question carefully. if we complete this problem for entire circle, if we complete this problem for entire circular path, how many times this path will be repeated?
4 times.
Anyone else?
D time.
How much?
4. 4.
Okay, now except for anyone having anything else, answer.
Mm.
3 times, sir.
Now three and without except three and four anyone कुछ और देखो हम लोग सात आप लोग सात लोग हैं दो आंसर हो गए थ्री एंड फोर अब बाकी के बचे पांच क्या आंसर दोगे आप एक दो तीन तीन तो आ गया एक दो पाँच छह सात बाकी है कोई आंसर दो
दो दो दो
तो चलो ये दो वाला कौन है मेरे को नाम थोड़ा बताओ अपना नाम बताओ
नील
ओके चलो दो हो गया फिर एनीवन एल्स precise correct answer is it will be three times see how much total circle is 360 degree and you are already covering 120 degree in one locus so another 20, 120 degree second locus so your 240 will be covered and last what will be balanced 120 so three locus will be there if we complete this entire part understood okay so now we are pointing this what we got the collection of points here 3 4 5 6 7 8 like this okay and we'll trace them that's it simple any doubt anyone
No, sir.
नो सर
please ask me if you are having any doubt right now you ask don't ask later on
No doubt.
so
कैन वी गेट दिस ऑल क्वेश्चन 1 to 25
I'm not getting your question possible
सर जो आपने 1 से 25 तक आज तक जितने भी क्वेश्चन कराए वो क्वेश्चन मिल सकते हैं
हर एक चीज तो करवाया है हमने
हाँ बट वो क्वेश्चन में थोड़ा गड़बड़ हो गया इसलिए
questions you need not to do everything first of all you understand that many things I have just explained you. You need not to perform that in your sketchbook or sheet. So what I will do, I will give problem statement to you. Everything what you need to perform in sketchbook and what you need to perform in sheet etc. Fine.
Yes, sir.
ओके
And if you want to do practice, you can take any book, any problem you can take, and there are steps also given and steps you know. So try to match your final solution is being matched or not. Understand? Is there any doubt in this first of all?
No, sir.
Okay, so our epicycle is clear. So now hypocycle. What will happen in hypocycle? I told you the definition that smaller circle will rotate from inside rather than outside. So I will go a bit faster. Every procedure is everything is same as epicycle. Everything except it will be rotating inside like this. So now, now one question for you all. If I want this blue circle to move here, to come here, I draw. I want that circle to be here, not here, be here. So how should it travel? In which direction? Direction of rotation I am asking.
Friday.
Anti-clockwise.
Anti-clockwise. Correct. Anti-clockwise is sorry. If it travels in this direction, then only it will move here. If it is outside, if it was here, we need to go in clockwise direction to reach here. Understand? And whenever circle is rotating, whether in straight path or curvature path, direction of rotation is important in giving names. In earlier case, it was rotating in like this. So we gave name 1, 2, 3, 4, 5, 6, etc. Here it is rotating in this direction. So we should give name in this direction. Understand? That we will see. So it is rotating in anti-clockwise direction. And now the same way theta is how much theta for this problem? Fast calculate and tell me what is the value of theta in this state, this problem.
Same theta, sir.
Same. Why?
120.
Why same? Because we have not changed problem statement.
Yes.
We have just changed in Hypo Cycle or Epicycle. That's it. Okay. So one more thing. If at times you may be asked this also, if one might question and CQ kind of thing, problem statement is given like this. Okay, that's it. The problem statement is given. You are not asked to draw whole this. What you are asked is whether it's epicycloid or hypocycloid or epicycloid, or just purely what type of curve it will trace. These kind of questions can also be asked. If you have understood this enough, then you can easily, by reading the name, okay, what is it? Okay, this is hypocycle. That's it. Understood. Okay. So this is the same. What is the next step? We will divide this in equal factors and transfer the center line. This is just for demonstration purpose. Last one. These are all the centers. How the center will travel. Why this circle will move from here to here. How center will travel. It will travel in only one direction. Whereas P will travel in two directions. This as well as this. These are all. Then actually here is one mistake. What mistake is that? First of all, there is an animation problem. There is first of all we divide this into 8 5. Understand? Are you getting me?
Yes.
Then these things will come. This path like this. Okay, it is coming like here. So there is some mistake. So first of all we divide this and then we will transfer all these points up to the end point. Up to here. Like this. Okay. Then we will give this name. See, name is in this direction. Now, now we will tell you what is the steps. This is our point P. Now this point is on top side because it is inverted. Now tell me what is the state?
आर्क CP arc CP लेके arc.
Okay, CP is the radius. Arc from C1. C1 on which line? From C1 on
Top
which line?
one.
You may say 1 7 line. This line.
1 sir.
Top line. Yes, correct. Actually, it is not top. Huh? Top is this.
Yes.
So there is also one point, and that point we will get here. So it is not top. Okay, fine. 1 7 line. Correct. This is here. From 2 to this 2 6 line. This is 1 2 to 2 6 line. Get it? 3 to 3 5 line. Like here. 4 to this 4 line. 4 is having single point. So 4 line. Like this. Bottom. Again 5 to this line. 6, 7, and 8. That's it. This is our Hypo Cycle. Clear? Any doubt to anyone? Anyone having any doubt?
No sir.
Okay. So within 15 minutes, we will complete this problem in our sheet. Maximum 15 minutes. Okay, I will also draw with you these problems that have hypocycles. Same problem. You write down or capture screenshot. Take your screenshot for the problem statement. I will stop sharing now. Just 15 minutes. You don't take much time because we should work fast. Hope my screen, my sheet is visible to you. It is visible. Is it visible, everyone? Am I audible?
Yes.
Okay. We should be completing in
15 minutes.
good. Now, one more thing. Just pay attention here, what I am trying to explain. Now, this is my page. Fine. And what we are going to draw? Hypocycloid. So after reading your problem statement, you should be able to gauge how much space you should be requiring. If I start drawing from here, first I take center here and start drawing, what will happen? My main portion will come outside the page. So after understanding the problem, how the orientation will be, that you should be deciding, and then you should draw. And here what we will do this hypocycloid in class right now, and on the same figure you will draw epicycloid on the same figure. There won't be any confusion as such, because that one is on top, so it won't disturb also. So what you do, you start at least from some reasonable center position. First of all, you mark this. What is that? That is the center of curvature. Now, how much distance is required?
75 mm.
Very good. 75 mm radius. You also keep doing with me fast. This EGED, whatever it is called, is very fast thing. You can complete whole question paper with option before time. And I am not joking. Many of you will do. Many of you. Now, first of all, this. Right now, I am not knowing what is my starting point. So I will first of all fix my starting point somewhere. That is up to me where I will start. So I will take my these as starting point. Now we know my end point will be how much, where it will be, how much away it will be, my end point. My end point on this side, it will be away how much? Answer me, where should be my end line here?
And line 120 degree.
120 degree from this line, correct? Because dimensions are such that theta is equal to small r divided by capital R into 360. That gives us for current problem 120 degree. So I will measure that 120 degree. Like this. This will be my 120 degree and this will be O. Now what I will do? I have unnecessarily, wait a minute, I need eraser. I don't know where my razor went. I got some fancy razor, by the way. What I will do, I will rub this extra line. I don't want this. But you should not get confused these extra lines with preparatory lines. These are not preparatory lines. That too, you will have some extension. Keep these extensions. Some of you should be way ahead than me in drawing. Now, what is the next step? We are having 25 mm radius circle. So, how you will identify the center on this line? You need to draw one circle here such that it touches here. How you will draw that?
What, sir?
You need to draw one circle here, na? How you will draw that? The rolling circle.
पेंसिल पहले कर्व पे रख देंगे.
Correct. And it is not pencil, it is compass. And then we will cut arc of required radius. Am I correct? So we got the center. Then we will draw this circle. Clear? Understood everyone?
Yes, sir.
Then what I will do, I will divide these in 8 equal parts. This is my point P. 1, 2, 3, 4, 5, 6, and 7. Nice. What is the next step? This is my center C. What is the next step? What is the next step fast?
Draw curves.
It is not draw curve, sorry.
So circle only.
This term extend the center line up to the end point like this. So what we will do here, extending the lines are very simple as compared to straight line. Straight line, if there is some error, it will go tilted. Here you need to just draw one arc like this. So it will be that line only. Like this. This is our center line. Then
what we will do? We'll divide this segment into 8 equal parts. Correct? We'll divide this curvature segment also in 8 equal parts. So this is 180. 180 by 8 means, sorry, 120 by 8 means 15.
15.
Correct? So I will mark 15, 30, 45, 60. Join them. Got it? So I will mark here C1, C2, C3, C4. Now what is the next step? Extend every point up to end point, end line. Now if your drawing is precise, then this arc will coincide with 3 and 5. It should also pass through 3 and 5. Same way, 2 and 6. If there is no error of any mm, smallest of the mm, it will pass through the both point. Okay. What is the next step? What is next step?
CP radius. CP radius लेके arcs बस.
Okay, I will take radius equal to CP first of all. Okay, CP radius. Now I will put my compass on center C1 and I will cut one arc on line number 1. Correct? And from C2 on line number 2. From C3 on line number 3. From C4 on line number 4. C5 on line number 5. C6 on line number 6. C7 on line number 7. So I will give them name now. That is P1, P2, P3. Got it? So we got all the points, and now we will join them freehand. And we will highlight our locus. This circle is also the part of our solution. So we will highlight that also. Everything else is just required for preparation. For generation it is required. Can you see? Can you see my answer?
Yes, sir.
Now show me your answer. इसका हो गया तो दिखाओ.
Sir, only 5 minutes, sir.
अरे यार 15 मिनट्स बोला था, कैसे चलेगा? बहुत टाइम लेते हो तुम लोग. मैंने भी तो तुम्हारे साथ किया, मैंने तो रबर ढूंढने में भी टाइम लगाया.
सर
कौन दिखा रहा है?
सर
हम्म
सर ये
कौन?
P1 P
बोलो.
सर ये P1 P2 कैसे ड्रॉ किया आपने?
पूरा तो दिखाया. कैसे क्या ड्रॉ किया? आर्क मार के.
हाँ सर, कहाँ से मतलब C1 से लेकर?
तुम कहाँ थे अभी तक?
नहीं नहीं, मेरा हो गया है, बस मेरा P का लाइन बाकी है, बस P का जो लाइन बना ना वो वाला, वो कैसे किया,
ठीक है,
आर्क
मत
कैसे किया आपने?
तुमने ये आर्क, तुमने पॉइंट्स लोकेट किए कि नहीं किए? आर्क मार मार के 8 पॉइंट.
हाँ वो नहीं किया सर, वो भी मेरा बाकी है.
तो वो क्यों बाकी है? वही तो मैं समझाया था, तुम कहाँ थे? ऐसा पूछ रहा हूँ. यही
सर
तो
मैं वो
हम डिटेल
ड्राइंग
में
कर रहा
समझाया. हाँ,
ड्राइंग कर रहा था मैं तो.
समझा रहा था तब की बात कर रहा हूँ.
और सर ड्राइंग कर रहा था वो टाइम पे मैं.
अरे डोंट डू दैट थिंग ना. पे अटेंशन व्हाट आई एम एक्सप्लेनिंग. Take your radius as CP, that will be fixed. Then put compass on C1, cut one arc on one line. Then from 2, cut the line on line number 2. From C3, cut the line 3. From C4, cut the line number 4. From C5, cut the line number 5. From C6, cut the line number 6. From C7, cut the line number 7. And from C8, cut the line number 8. We will get this locus. उसमें किया है तुमने सेंट्रोइड, साइक्लोइड, इंफीरियर ट्रोकोइड और एक्सटीरियर ट्रोकोइड किया? हेलो, मैं जो
यस
पूछ
सर.
रहा हूँ वो बताओ, तुमने किया है?
हाँ यस सर.
दिखाओ. इंफीरियर ट्रोकोइड स्ट्रेट पाथ पे जो मूव करता है, वो प्रीवियस क्लास में करवाया था. वो इंफीरियर ट्रोकोइड और सुपीरियर ट्रोकोइड. ये नहीं, प्रीवियस क्लास में जो करवाया था वो इंफीरियर ट्रोकोइड एंड सुपीरियर ट्रोकोइड. किया है वो? नॉट एबल टू सी, कुछ दिखाई नहीं दे रहा है। I'm not able to see. Show me that drawing. Correct. Nice. Tanuj, very good. But your this segment line or what you divide these things, that lines are too dark. See my drawing. Can you see? You can hardly see those lines. Okay, your thing is correct, but the lines are too dark. Nice, good. Switch off your video. अमल तुमने पहला किया है, मैं ऐसा पूछ रहा हूँ. Superior trochoid, inferior trochoid, cycloid वाला. If yes, show me. कुछ फिजिबल नहीं है. Anyone else? किसी और का हो गया हो तो बताओ फटाफट.
सर मैं ध्रुव सोना.
हाँ तो बताओ कहाँ है.
सर अभी ये गणेश दिखा रहा है, वो देख लो.
हाँ सही है गणेश, करेक्ट. लाइन थोड़ी स्मूथ और लाइट करो, बहुत डार्क मत करो ये सब. चलो नेक्स्ट.
सर अब मेरा देख लो. सर
करो थोड़ा ऊपर,
ऊपर
थोड़ा
करो.
राइट, राइट थोड़ा राइट, तुम्हारी राइट थोड़ा.
हाँ
नजदीक लाओ, नजदीक लाओ, नजदीक लाओ, नजदीक लाओ, कैमरे के नजदीक लाओ. और अभी थोड़ा ऊपर लो, थोड़ा ऊपर लो, थोड़ा दूर ले जाओ, थोड़ा दूर ले जाओ, हल्का सा. बस करेक्ट है. नाइस नाइस.
ओके सर.
नेक्स्ट. एनीवन एल्स? अमल दिखाओ भाई तुम्हारा पहले का किया हुआ कुछ. दिखाओगे कि नहीं दिखाओगे? ब्रिजेश हो गया? रौनक?
सर आर्क मारना बाकी है, मैं कर रहा हूँ.
नील फटाफट करो भाई, कितना टाइम. अमल कहाँ चला गया? कुछ आंसर ही नहीं दे रहा है. So ultimately it travels like this. If you can see, it travels like this. Initially it is, this arrow is like this, slowly it travels, take inverted position and again get back to the original position. Understand? You need not to show these lines, arrows. I'm just showing for your understanding purpose. Fine. So if I draw one circle here, it will be like this. The same circle. You need not to show these. I'm just showing. So now what you need to do in homework is you need to draw hypocycloid, epicycloid by your own.
सर
Yes.
सर एपिसाइक्लोइड में ऊपर सर्कल कैसे बनाए सर?
एपिसाइक्लोइड में
सर्कल हाँ ओके समझ गया हाँ
सेम
समझ
वे
गया लाइन एक्सटेंड कर दी ना सर थोड़ी
हाँ
ओके गॉट इट
it is like this. I have just shown you. See?
हाँ दैट्स
See, if you practice by yourself, then only you will understand these things. There is nothing as specific in this. It is very simple, logical things that will click only if you do it properly. Okay, so now we will go further. We are losing too much time. We need to finish few things.
My screen is visible.
यस सर
So this we have already seen. Now we will see another type of curve. This is already we have seen hypocycloid. Now we will see spiral. As I told you earlier, what is the spiral? It is a curve generated by a point which revolves around a fixed point and at the same time it moves towards it. A simple example of that. Everyone may be having headphone right now. Hold your headphone from the jack and rotate it over your head as if you are rotating something 3D. Fine. Now when you stop, the earbuds will travel in spiral direction. As your movement will stop, what will happen? It will keep rotating around the axis of your head, but simultaneously it will come near to your body also. So if you see from the top, it will be the spiral revolution. Everyone getting what is spiral?
यस
Is any doubt in spiral? Same way, हम दिवाली में जो पटाखे लगाते हैं उसमें जो चक्री जलाते हैं, सेम चीज. It also revolves around center and slowly moves towards center also. Fine. So how is the spiral we will draw? It is very simple. Spiral is very simple. You pay now. Stop doing everything and pay attention here. Draw a spiral of one convolution. What is this convolution? That I will tell you. Take distance PO is equal to this much. Convolution, we will discuss it. First of all, you need to draw a spiral. So the important approach of construction is that find total angular and total linear displacement and divide both in the same number of equal parts. Understand? What is that? I will tell you. Now this is one circle. We divide it into 8 parts. And this is the PO. This is the distance given PO. What is this given? Na? PO 40. It is this. So that much radius, we draw one circle at first place. Then what happens? I will tell you. Now this P point travels in circular as well as linear motion. Understand? It travels around this axis O. It travels around this axis O. Fine, OP. And also it travels inwards. So it is having two movements. One is circular and one is linear. So what this box is telling, you divide both in equal parts. Now we have divided this circle in how much parts? 1, 2, 3, 4, 5, 6, 7 and 8. So we will divide this line also in 8 parts. If we divide these in 20 parts, we will divide these also in 20 parts. Likewise. So what do I mean by convolution? Now this will start and it will, wait a second. Now what will happen? It will go, what is this? It will travel like this, spiral. So slowly inward पे आएगा and it will stop somewhere here. Now it has started from this position. If we take this as coordinate system like this, so it has started from positive x-axis. Fine. And again, if it comes back to the positive x-axis, that is called one convolution. Are you getting me? What is the meaning of one convolution? Are you getting? See, this is just approximation. What
Yes, sir.
I have drawn with pen. This is just approximation. It may be precisely. It will be sorry. Uh, it will precisely be like something like this, like this. So if two convolution, then see my distance, my traveling will start. This is first. This is second. If it's three convolution, I will keep on moving, and this is three. Sorry. Understood? Meaning of convolution here. Everyone, any doubt? Please ask me right now.
No, sir, no doubt.
So this is the procedure. So what is that? Circle is also means total circular distance. How much it is traveling? How much circular distance for one convolution? How much circular distance it is traveling?
0.5.
Huh? Circular distance here.
Oh,
Angle. Starting from here, and it may end up somewhere here on positive x-axis also. How much distance it would have traveled?
Pi d means pi d.
Distance in angle. I am angular distance. I am just want. Huh? Okay. No 260. It is wrong. You just answer me. If it is here and if this comes here, how much distance it has traveled? Angular distance.
90,
90. Here,
180,
here,
270,
and here.
360.
360. So in one convolution, it travels 360 degree. Now, if we are having two convolutions, then how much travel it should be having?
720.
720. So likewise, you maybe ask some twisted question also. Okay, 1.5 convolution or say 3/4 convolution. So one convolution is equal to 360 degree angular. So if you are given that 5/4 convolution it has traveled. So how much degree it is? How much degree it is? If 5/4 convolutions.
450.
Eh?
450.
450, correct. 450 degree. So you can be asked this MCQ kind of question also. Are you getting? So any doubt about convolution? What is the convolution?
No, sir.
No. So what we did, we divided circular motion, its total circular motion in some 8 parts. Okay, so we need to divide this linear motion also in 8 parts. How we will do? First of all, we will give name. Now we have divided them also in 8 parts. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now what we will do? We will take radius 1 from 0. It is 0. I will mark O from 0. O. This is O. So O to 1 is radius, and we will draw one arc up to line 1. This is 1, so up to 1. Similarly, O to 2 radius and circular line up to line 2. O to 3 radius and circular line up to line 3. O to 4 up to 4. O to 5 up to 5. O to 6 up to line 6. O to 7 radius up to line 7. O to 8 is the center point. Any doubt in this? Anyone?
No, sir.
Amal, are you there? Okay. So what we are getting? We are getting the collection of points. This was the initial point. Fine. Starting point. Then we got this intersection point. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, then 8, 8. And join them. Give them name. And join them. This is the spiral. That's it. Is there anything specific or confusing? How to draw spiral? Spiral, I think, is the easiest of lot, isn't it?
Yes, sir. Yes.
And it will be the quickest also.
Mm.
Okay. Any doubt, anyone, please ask me right now. Don't ask me anything later on. Any doubt, anyone? Okay. So now,
No, sir.
okay, so we will see two convolutions now. Okay, in this one I will go quicker because we know the procedure. That is, what will be the difference? Only one difference is there is now parts are divided into, see, these are 8 parts, but assume that these are divided into 16, and that's how I will tell you. This line is divided into 16 parts. Okay, so what will happen? This is 1, 2, 3, 4, 5, 6, 7, 8. This is for one convolution. Then again 9, 10, 11, 12, 13, 14, 15. So you need not to divide this in this way, 16 parts. Understood? It can be divided like this. For one convolution, this much distance. Two convolution, we have taken this much distance. And this is already divided into 16 parts. Okay. So then we'll give them name and same way. Mark this is center O, O to 1, line up to 1, O to 2, line up to 2, O3, line up to 3, O4, line up to 4, O5, line up to 5, O6, O7, O8. Okay. Then again starts O9, this, O10, because this is also 10 also. Then O11, O12, O13, O14, and O15 and O16. Everything is one. So first collection of point now we will trace. 1 intersection 1 is 1. This is 2, 3, 4, 5, and 5, 5, 6, 6, 7, 7, 8, 8. This one convolution is over. Now 9, 9, 10, 10, 11, 11, 12, 12, 13, 13, 14, 14, 15, 15, and 16 center. Got it? So this is it. Is there any doubt? 2 convolution is also given then.
No, sir.
Can you do it easily?
Yes, sir.
Okay. So now this is a name is animation problem. The name is coming right now. It is not big issue. Now we will see the tangent. This has been covered, I think. Is this covered in previous class? Tangent to an involute. Quickly answer me.
No,
No, then okay, we will start. So this involute you are already having in your sketchbook. Simple method is very simple. What you need to do, understand here. This is some given point through which we need to draw tangent and normal. Got it? This much is clear?
yeah.
Okay. Now you connect it to the center like this and take that much diameter and draw one semicircle. Again, I will repeat. Point is given, connect it to center. Now that point and center, that much distance is diameter, draw one semicircle. That semicircle will cut at some point to the base circle. Are you getting it? That base circle intersection point and given point is the normal. And the perpendicular line to it is tangent. And out in this, you can do in your sketchbook. There are 3 simple steps. First, any point is given, okay, you mark that, identify that. Okay, then you draw that with center of the rolling circle. Okay, that is fine. Then that much diameter, you draw one semicircle, which will cut the base rolling circle at some point. Now join given point and that last point which we got by intersection, you connect those 2 points. It will be your normal. And the line perpendicular to it will be the tangent. Is there any doubt in this?
No, sir.
Should I repeat or move?
No.
Okay. So this is the involute. Now cycloid. You are already having cycloid with you. Cycloid you are also having with you. Fine. So this is the given point. Now what we will do? That given point with radius equal to Cp. What radius we used in whole problem, that Cp radius. You take that much radius. Fine. This much is the radius of arc. And from given point, you cut one arc on the center line. Center line means this line which is having all C's, C1, C2, C3, C3, 4. These all are center line. So you will get one point. Okay. Then that is the CP radius what I told you. Then you transfer that point to the straight line path like this, bottom. Transfer by perpendicular line to the bottom straight line path. Understand? Now that point and given point you join, that will be your normal. And the line perpendicular to it will be your tangent. Any doubt in this? Anyone please ask me right now. And these all things you are having in your sketchbook. This involute we also did, cycloid we also did, spiral, that is fine. Spiral is not done, that is not required. You can do for your practice by your own. And we have already drawn this hypocycloid also. So all the curves we are having with us. You need to just draw tangent and normal to any arbitrary point. Fine? This is normal and this is tangent. Now we will do this to our spiral also. You just know what is the procedure of this. Now in spiral there is one thing. Now pay attention here. For spiral, has someone drawn spiral with me?
No, sir.
Okay, no problem. Now in spiral, if you want to draw tangent and normal, now this is some specific thing. So this can be asked. It is some typical thing. You need to find one item which is called constant of the curve. It is given this name, constant of the curve. What is that? It is a difference in length of any radius vectors, an angle between those two radius vectors. It is given also here. What are this? If I take OP, this is first ray, my vector. What radius it will be having? In the problem we were having the 40 mm. So this will be having
Yes.
40 mm. Okay. Then we are what he has taken OP2. So this, if this, so it will be having some less than 40. Understood? Some amount less than 40. So you need to, for example, it is having 30, for example. Then what is the angle intercepted by these two? Angle intercepted by these two?
90.
90. But here you should write it in the form of radian. That is 90 degree. But if you want to convert it into radian, then you need to multiply it by pi and divide by 180. That is degree to radian. And if you want to convert radian to degree, then given angle, whatever it is, into 180 by pi. Clear? How to convert degree into radian and radian to degree?
Sir, voice is not clear.
Sorry?
सर वॉइस नहीं आ रहा था.
Is screen visible now?
Yes, sir.
So, as I explained you, if you take two radius vectors OP and OP2, so the denominator is numerator is difference in their length, and denominator is angle in radian intercepted by those two. Now, if you take this OP and OP4, the length will be whatever. What will be the difference in angle? If OP and OP4,
Pi.
pi, correct. So accordingly, this will remain constant. This will be same. The interesting thing is that This will be whatever you get for your problem. This value will remain constant whether you take any two pair. If you take these and these, or if you take these and these, or if you take these and these, whatever you take combination, this answer will remain same. It won't change. So you please note this down, this thing. With or say you can take screenshot also. So what is the next step? You need to find this constant of the curve. After the finding constant of the curve, you need to take that much radius, this much radius, and draw a circle at the center like this. Constant of the curve radius, draw one circle. Now you draw tangent from given point to that circle like this. It will be the normal to the spiral. Draw tangent to the smaller circle from given point. It will be your normal. Simple. And line perpendicular to it will be your tangent.
सर
हम्म
सर ये रेड डॉट कहाँ से आया वो बताओ मेरे को
क्या कहाँ से आया?
ये क्यू पॉइंट क्यू
Q तो गिवन पॉइंट है, तुम्हें दिया हुआ है कोई भी आर्बिट्ररी पॉइंट.
हाँ ओके 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 ओके
कोई भी आर्बिट्ररी पॉइंट है, उस पॉइंट पे हमें टेंजेंट एंड नॉर्मल ड्रॉ करना है. So any doubt anyone in this, how to draw tangent normal to engineering curves?
No.
Okay, so these ultimately come with these, we ultimately comes to the end of the session. Fine. So engineering curves as such is over. If you want to ask me anything, you can ask. If you have any doubt, you can ask me. What you should do in the sheets or drawing sheet, drawing sketchbook, I will tell you. In detail sheet, I will send either of anyone and among it will be circulated. Fine. Is there any doubt? Anyone? बहुत सारे लोग लीव कर गए.
थक गए.
Okay, they will get tired in exam also. Don't mind. Okay, we'll end this session. Thank you.